All right, module 19, last part. We're going to talk about transformations today, and various translations that we're going to do to our quadratic functions and compare them to the parent function, which we talked about the parent function since Monday, since we started this unit. Parent function of a quadratic equation is y equals x squared. So we're going to look at what happens when we change the h values and the k values in a quadratic equation that's in vertex form, and we'll see what happens and how it compares to the parent function. And that's what we're doing today. So let's get started. So first off, the parent function of a quadratic equation, or the simplest quadratic equation, is y equals x squared. Okay, and a transformation is when we change the size or position of our quadratic equation in terms of the parent function, okay, or in relation to the parent function. And that's what we're doing today. It's similar to our transformations when we were dealing with absolute value equations. So you could think of it that way as well. Now, let's talk about our horizontal translations. So on our graph here, we have y equals x squared. It's already graphed. Now, if you don't have it on your graph, then please go ahead and pause the video and graph y equals x squared. You should know how to do that at this point in module 19. But go ahead and graph it, because we're going to add another parabola to this coordinate plane, and we're going to see how it compares to this original parent function. So again, if you don't have y equals x squared on a coordinate plane already, please graph it, and then we're going to put another graph on the same coordinate plane and see how it compares. All right, so we have y equals x plus 2 squared. Now, would this be in standard form or vertex form? It looks like it's in vertex form, which is y equals a times x minus h squared plus k. So because it's in vertex form, we could easily identify what our vertex is. So our vertex is going to be, well, what number's in the h position? It looks like h is going to be -2. Remember, h is opposite. And what number's in the k position? It looks like it's going to be 0. Remember, this is the same thing as saying plus 0 over here. So our vertex is going to be -2, 0. All right, and we add some more values here. And we solve. So at 0, we would be at 4. At -1, we would be at 1. At -3, we would be at 4. And at -4, we would be at, at -3, we would be at 1. And at 4, we would be, at -4, we would be at 4. Okay? Let's go ahead and graph it, and I'm going to graph it in green so you can see how this parabola looks like in comparison to our parent function. So we have -4 and then +4, which is right here. Then we have -3, 1, which is right over here. We have -2, 0. We have -1, 1. And then we have 0, 4. And there is your parabola. So if we take a look at this, what changed? Okay, well, it looks like the only thing that's changed is that we shifted our entire parabola to the left 2 units. All right, now why did we shift our entire parabola to the left 2 units? Well, if we go back to our original quadratic equation, what we started with, y equals x plus 2 squared. Now, what do you notice in the h position? In the h position, we have that -2, because remember, h is opposite, right? And when we're talking about transformations and when we're doing translations of a quadratic equation, this h is what controls the horizontal. All right, the horizontal meaning left to right. So because we have h equaling -2, what that h does is it shifts our entire parabola over to the left 2 spaces, because it's -2. Okay? Our parent function is y equals x squared. So what did we do to our parent function? We added that +2 in the h position, which would make it a -2, and that's why we shifted 2 spaces to the left. So if I were to write another quadratic equation like y equals x minus 5 squared, right? What would that do? Well, that would just shift our entire parent function, our entire parabola, this time to the right 5 spaces. So my vertex would be right here. That's all that change is doing. So when we change that h value, we're shifting to the left or to the right, depending on whether that value is negative or positive. That's all the h value is doing. It makes it shift in the horizontal, okay? And we call that a horizontal translation. Horizontal translation is a shift of the parabola left or right, but we're not changing the shape of the parabola, and we're not changing anything in the vertical, just horizontal. Sorry, I forgot to put one thing here where it says transformations. So what was our transformation when we changed that h value? It looks like we went to the left 2 units, not 1 unit, 2 units. And that's all you'd have to do there where it says transformation. Let's take a look at this one. Again, y equals x squared is already on our coordinate plane. If it's not on yours, please go take a moment to pause this video and graph that. Now this time, we didn't add anything in the h position, but we did put this plus 5 here. Now remember, our original parent function is y equals x squared. And what we're doing now is we're changing the k. The number in the k position is 5. So let's first identify our vertex. Remember, vertex is h comma k. Well, the number in the h position is 0, and the number in the k position is 5. So your vertex is going to be 0, 5. All right, and then the number up and down. -1, -2, 1, and 2. And we start plugging away. All right, so if we plug in -2, we get 9. If we plug in 1, we get 6. If we plug in -1 is what I meant to say, we get 6. If we plug in 1, we also get 6, and if we plug in 2, we get 9. Let's go ahead and graph it and see how it looks in comparison to that parent function. So -2, 9 would be off of this coordinate plane. It would be somewhere up here. And then -1, 6 would be right here. 0, 5 would be right here. 1, 6 will be right here, and then 2, 9 is going to be somewhere around here. So again, we didn't have any change to the shape of the parabola, and this time we didn't have any change in the horizontal, but we did have a change in the vertical. And that's because k, when we change our k value, that's what determines our shift in the vertical, whether we're shifting up or down. In this case, k was a 5, and that's why if you look at our graph, the graph of y equals x squared plus 5, what it was a shift up of 5 units from the parent function. It shifted up. So if this would have been y equals x squared minus 7, what would that have done? That would have just shifted the entire thing down 7 units. The vertex would have been there, but the shape of the parabola would have still been exactly the same. I'm sorry, I forgot to fill out one part here. So where it says transformations, what was our transformation when we changed that k value? We just went up 5. That's what you would put here. All right, now pause the video and try to think of what is going to happen to our new parabola now that we have a change in k and a change in h and a change in k. Well, remember, h is what controls the horizontal. So if we look at this, h is going to equal -1. So because h is -1, that probably means that we're going to have a horizontal translation of 1 unit to the left. Now k in this case is -6, so k is what controls vertical, so that probably means that we're going to have a vertical translation of 6 units down, okay? So let's see if that actually happens. So our vertex is -1, -6, and then we just add some values, -2, -3, 0, and 1. And then we plug away. Let's see, if we plug in 1, we get -2. And if we plug in 0, we get negative 5. All right? And if we plug in negative 2, we also get negative 5. And if we plug in negative 3, we get negative 2. All right, let's go ahead and graph this. Negative 3, negative 2 is right here. Negative 2, negative 5 is right here. Negative 1, negative 6 is right here. 0, negative 5 is right here. And then 1, negative 2 is right here. And we draw our parabola. Now, let's see what happened. Our vertex is here now. So it looks like we did shift to the left 1 space. And what else happened? It also looks like we went down. Let me do that with a different color. We went down 6 spaces. So we went down 6 spaces and we shifted to the left 1 space. And we could have immediately figured that out just by looking at our equation in standard form. So over here where it says transformations, I forgot to do this with the last example, so please add this in the last example, or the last 2 examples. But what you would put over here where it says transformations is all you would have to write is left 1 and down 6. Let's fill some of this out now. H is some of this we could already fill out. We already know what H is. H is a horizontal shift. Horizontal shift. So if H is positive, we shift to the right. And if H is negative, we shift to the left. But remember that H is always going to be opposite, right? H is always going to be opposite. K is the vertical shift. So if K is positive, we go up. If K is negative, we go down. A, now we didn't do any problems like this today or in this video, but we have done problems where A is negative, and what does that do? It causes a reflection. So if A is negative, the function is reflected or flipped across the x-axis. Now we're going to talk about these last 2 tomorrow. We'll do some examples where the absolute value of A is greater than 1, and we'll do some examples where we have a fraction less than 1, and we'll see what that does to our graphs. But you should have this down in your notes, and you should know what happens when we change our H, and when we change our K, and what kind of transformations occur when we do that. All right, that is it. That's the end of this video. Have a great day.